Record.
It was the like get length of the longest run of like here, I'll do got it. Increasing or decreasing within an array of integers, right?
Okay. Do you want to just? I might have it. Do you have it like in front of you? You just like paste it into the Zoom chat.
I do not, but I have it in our text. I'll do that one second.
Oh, okay.
Let's see. Here it is. Yeah, a consecutive run, this one. Okay. Chat. Okay, there we go.
Cool. All right. How was this one, by the way? I hadn't done it yet, so
I liked it. I thought it was good.
Okay, cool. Yeah, I feel like it's probably very different from like the ones you've been doing on LeetCode, just because it just stylistically LeetCode is a very specific style of
Yes,
problem.
that's very true. Yeah.
Okay, so it's going to, there's a lot going on the screen here. Let's bring that down. Okay, an example. Okay, and then this is like there. Okay, so put that there. I'm gonna grab, I've been using this like template recently.
Oh, sweet.
Just for like practice, to try to have a consistent style how I approach problems. Okay. And then I'll start a timer. I'm gonna shoot for 30, but we'll see. Do you have enough time? Like is 30, like 40, is that good for you today?
I got all the time. Yep, I'm totally free today. So
You're on that unemployed coding grind just like me.
yes, yes.
Okay, let's get started. So consecutive run is a list of adjacent consecutive integers. This list can be either increasing or decreasing. Okay. Create a function that takes an array of numbers and returns the length of the longest consecutive run. Okay. If there are no consecutive runs, there is a gap between each integer. Return 1. Okay. There's a couple like terms here I'm just going to grab. So I feel like gap just kind of refers to like anything, like any character, any non-integer character. Okay, and then it's going to be consecutive integers. So then this is, wait. There's a gap. What does this mean? If there aren't any consecutive runs, there's a gap between each integer. Okay, so I guess gap is just, so it's, can I assume that the input list is always going to be containing integers only?
Yeah, yeah.
Okay, so list only ever contains ints. Do I have to think about any like special numbers like infinity, not a number? Okay. Always ints. And this gap is just like a situation where they're not consecutive ascending or descending. Not consecutive ascending, descending. Yeah, okay. List of adjacent, so it must be adjacent. Okay, so requirements, essentially for this, so a consecutive run, that's sort of like a key term here, consecutive run. If you grab this, I'll just paste that here. Consecutive run, for that to, for something to be considered that, it must be one after the other, so one after the other. And that must consistently be in one direction. One direction. And that's just meaning like ascending versus descending. Okay. This list can be either increasing or decreasing. Okay. Create a function that takes an array of numbers and returns the length. Okay, so we want to store lengths as well, and always ints. Okay. Do I have to worry about like a situation where it's in like an empty list or something? Or is that
Um, you can if you want to include it. I didn't see it in the prompt, that's so yeah.
okay?
You could have
Fair
a
enough.
check in the beginning if you wanted. I
Yeah,
don't know.
I might just like add some specific to like the style that they're gonna ask me. So like maybe like sparse as well. Um, but I'm going to keep this condition consistent where like if it has anything in it and it's not sparse, those elements will be integers or numbers. Okay. So, and then our output is just going to be some integer. So integer corresponding with length of longest consecutive run. Consecutive run. Okay. So that's fair. We've got that. As far as like the data flow, I suppose I should start thinking about some of the test cases. So this is called longest run. So there are two consecutive runs, 1, 2, 3, and 5, 6, 7, 8, 9. So we'd want to return length 5. Okay. So we'll grab this test case just as our base case. All right. Get rid of that. Longest. Okay. And this wants to return 5. We're to iterate on that. Maybe we do like 1. We can just get rid of like 100 or something. This would be 5, 6, 7. How would we deal with a case like this where we have two runs of the same length? Should I return the one that I encounter first, or should it be some other condition?
I think it doesn't matter which one because either way you'll be returning the same number,
Oh yeah,
right?
yeah. You're right. It's just
If it,
it's
yeah,
just about the length.
I hear you if we had to return like an array, yeah. So,
Okay, yeah, that was my bad. So if yeah, so that's clear. Okay, so this would be 3. Okay, and then and add a test case like just empty array. And this would just return 0, presumably. If there aren't any consecutive runs, okay, I think this might. Would this be lumped in with this condition here if there aren't any consecutive runs?
yeah, I would
Um,
think so.
okay, so that would be the same, and then this would be maybe like 1, 3, 3. Okay, and then consecutive ascending. So this would obviously not be a run, and then be something like this, 100, 7, 9. So then this would be 1. Oh yeah, and then this was also the one. Okay. So we've got a couple of those. Do I have to worry about negative numbers? Does that matter? I don't think so.
No.
Yeah, doesn't matter. Okay, so got that. Other requirements. As far as like the data flow is concerned, we're intaking an array. So just array can be empty or sparse. And that's essentially transforming into some integer return value. Okay, and then our algorithm is right here. So it seems fairly good. So, and I feel like I've identified edge cases so far. So, and then I usually try to like just summarize the problem in like a sentence or two, just to, I don't know, it kind of helps me sometimes. So given some list of integer values, return, or I guess calculate the longest consecutive ascending run, and return this value, and return the length of the run as an integer. Okay. So that's our summary. And as far as steps go, I'm just gonna pull this stuff down. Okay, and then I'll just preemptively do that. So we got that. Got some test cases. All right.
Quick question. In your
Yeah.
summary, are you gonna only be doing ascending or descending as well?
Yes, ascending or descending. Yeah. ascending, descending, run. Yes. core aspect of the problem there. Shoot. Okay, so let's see. We're at 20 minutes. Let's see if we can hammer out an algorithm here. So let's think about this. We definitely want to like traverse the array, traverse input array. And we definitely want like some sort of place to like store. Like I think we could just start like with like a pointer or something. So like declare longest run, and this could be like negative infinity just to start out. And as we traverse the input array, we want to be like building up maybe some sub, like honestly, maybe just the I'm thinking maybe we just build an array based on if they are consecutive ascending. But I'm not even sure if we need to do that. We might just be able to I'm gonna have another one here. So declare current run length. Okay, and that's just going to be initialized to 0. And as we're traversing, we're checking, okay, so first of all, so it's kind of like a sliding window a little bit. So maybe traverse from index 1. So we would be starting like here. And again, this is assuming that it's not empty or sparse. I'll just write that here as well. Const sparse, this, and then sparse length 5. Okay, and then console log longest run with sparse, and this should, I feel like this should return it should return 1, I think, because there isn't anything in it. Okay, seems fair. And so I guess that would just qualify as like guard against guard against sparse and empty input arrays. Okay. And as we traverse this with like a window, so looking at these two elements, seems like we would want to, first of all, check to see if they are ascending. So I guess that's something for each time we encounter a new pair, we need to check if it's ascending or descending. And maybe we want like some sort of variable to keep track of what it was before that initial that current comparison. So maybe like declare like is ascending. And we'll just start that to we can probably initialize that to, maybe we take the first two elements and check to see. So we'll just do like check first two elements in array to see if ascending or descending. So that would just be something like whatever, like the first two array at 0. So if that is greater than or if that is less than first two array 1, right? So then if this expression evaluates true, then is ascending is true, otherwise false. So that's like the initial value. So okay, that makes sense. So as we're moving across, we have this window that's sliding across the array, and every time, so first I guess the condition initially is do the two elements so are the two elements is element right, or yeah, I guess is right element 1 greater or 1 smaller. So I guess we need like something first of if it's ascending or if it's descending. So maybe we'll do like if is ascending, then do the following, else do something else. So if it is ascending, then we'll do this. So is right element is right element minus 1 equal to left element. So if that is true, and we have entered this portion of the logic, then I think we can increment maybe like a counter up here. So current run length, maybe like current run length plus plus. So increment that by 1. And then if not, then we would want to check to see if current run length is greater than longest run. And if it is, then we would want to reassign longest and just run to current run length, current run length. Okay. So if it is ascending, we're checking if it is ascending plus 1, and that's true, then we're incrementing. If not, we want to check to see if that is greater than longest run, and we want to reassign longest run to the current run length. Okay, and then else, this is just if. This is if descending. So just negating the value of is ascending, if is descending, then we want to check if left or if right L plus 1 equals left L. Is that right? So if it right element, why am I doing it like in the inverted way that it should be? This is just, it's not very intuitive. Putting left on right and right on left. So if left element is equal to the right element minus 1, then that's good. So then if right element, minus 1 is equal to the left element, then we want to increment current run length by 1. And if not, it would be the same logic there, I believe. Okay. And so we're essentially just traversing this with a window. So we're to like jump over here. For this first test case, this is, and maybe I should have, I'm gonna grab this test case. Well, actually, I'm gonna grab this test case, and I'm just going to flip these numbers. So 3, 2, 1, just to have that coverage for when it starts out as false for is ascending. Okay, and then I think some of the details will be a little bit more clear when I'm actually implementing this as code. I'm trying to think, I should probably run through this though, about 13 minutes. So I'm looking at these two. We'll have some variables. So longest run is negative infinity. Current run length is 0. And then is ascending, we're checking the first 2 elements in the array to see if it's like the initial direction, ascending or descending, is one or the other. So for this one, we're looking at these two and we're saying, okay, so is ascending is true initially. And okay, so that's true for that. So we're starting our loop, and the current window, so I guess just like left is 1, right is 2. And so if we're looking at our algorithm, so if 1 plus 1, so here, first of all, is ascending, great. Oh, and I'm thinking if this is not the case, then we also need to reassign, or I guess negate is ascending value, because if this is not equal to that, I feel like I'm a little bit turn around here. I don't know why I'm thinking about this weird. So
Probably because bool is kind of hard because then it might jump into the else. Oh, no, it wouldn't. But yeah.
yeah, I know that there's probably still something wrong with how I'm thinking about this, or like how I'm implementing it. So we're looking at this one.
Do
We're
you want me
thinking,
to give you like a quick pointer? I know sometimes interviewers can help a little bit.
sure, yeah, no, if there's something
I,
that I'm like, yeah,
yeah. I was just wondering if on line 51, if you could just check that without having the bool of is ascending. Like you could just go directly into checking that, and then
Mhm.
you could continue checking to see if it's ascending. I don't know, just a thought, but
Yeah. So you're saying like this is sort of like this operation I'm like kind of doing initially up here, but then we want to consistently do it. Um, yeah. Okay. I think you mean, yeah, that's definitely a good point. I
but
think,
keep doing what you want to do, like if you want to keep on your track and stuff. So
yeah, no, I mean, I think that makes sense to like, if this condition is true, then we want to do something. So this would essentially just mean like ascending.
because then you're not
And
like double checking.
yeah, yeah, that makes sense. Um, I think I got like stuck with thinking about is ascending initially. Like I needed an initial value, which I guess isn't technically true. I could just get that initial value as I start the loop. Yeah. Okay, so if I'm here and we're checking if left is equal to right, this is true. So then we want to increment current run length. And then we want to continue to the next step in our loop. So then we would be incrementing I, get new. So we declare left, right, and then assign them to their respective values. So that's every time. Okay. So then we move to the next one and we're seeing, okay, 2, 3. This is also ascending. So then we're incrementing. We're going to get rid of this. The current run length, I think, what it was called. So currently this is at 2. So it's here. I guess it should even be initialized at 1 instead of 0. Yeah, because then, yeah, okay, so then this, so once we get to the third, so when I is 2, we're at this element, and that is when we would no longer be seeing some ascending behavior. So we can just do if, so then I honestly, it's just else, honestly. We would, so else,
quick question about the else. What if it's like it could be like descending or it could be ascending, but not in or like not by
not by 1.
yeah.
Yeah. That's a good question. I think, yeah, that's definitely right. So if it is not ascending by 1, then it could either be, I guess that would just be like else if left element, equals right element minus 1, then that would be descending. Okay. And then else, this is just a case where it's neither descending. Well, it could be ascending or descending, but the difference between the two elements is not like consecutive 1, 2, 2, 1. So then what would we do there? So that's actually when we hit here. If we go 3 and 5, this is not evaluated. This is not evaluated. So we move to the else condition. And there we just want to, I guess, like check. So here we would probably have maybe like some value. We would essentially want to like 0 out, or I guess 1 out the current run length. Run length be initialized or be reassigned to 1 unless it was some value, some value greater than 1, I think. So I think we just push, or this is okay. So we need to check to see if that is greater than longest run here. And then we would zero it out. So setting it to 1. Okay. This is so messy. All right, let me think about this. So we just like define a function here, longest run, input, and we need to guard against sparse arrays, right? So if it's not an array, we would just want to return invalid input. Okay, and then if input length is equal to 0, then we just want to return 1, right? That was this test case. Okay, so then technically there's still a sparse array here. So I think there's a way to like check if input at index 0 is equal to undefined, then we just want to return what were we saying for sparse? Just 1. Okay. So I'm just gonna move those up here just to get that out of the way. Okay, so exit node. Oh, we're not even in this folder. Node length longest. Yeah. Okay. So we're seeing 1, 1, and then 4 undefined. So that's what we expected. Okay, so that guard clause is settled. Now to the actual algorithm. We're going to declare longest run. So just do let longest run equal to -infinity. And then we want to declare current run length to 1. Current run length is 1. And okay, and we're not doing this actually. We're not doing that. Okay, so then we want to traverse it as like a sliding window. So we're thinking just like a normal for loop here, index and input. And we're actually going to start at 1, and then it'll be let left equal input at index I minus 1. Okay, and then let right equal input I. And that seems fair. Just log out those 2 values just to ensure that everything is working right. We'll just comment that stuff out. So if we run, we're seeing 1, 2, 2, 3, 3, 5. So those are like the pairs we're going to be comparing. So we've got that. Okay, so declared. So then we're checking if it's ascending. So if left element is equal to right element minus 1. Then, so this is just ascending. And then else if left is equal to right element minus 1. Wait, that's the same. Why am I thinking? So left needs to be greater for it to be ascending. So left equals right minus 1. Why is that? Am I just crazy?
No, it's plus. I think it's wait.
These sort of things bug me so much when it's like it's one or the other.
I think it's left minus 1 and for the bottom one.
Okay, wait, so left would be yeah, you're totally right. Always the plus or minus 1 stuff.
Wait, if left is left minus 1. Yes, okay. Yep, okay.
And then this is night, so this would be neither. Okay. So we're thinking about this. If it is ascending, then we want to increment current run length. So current run length plus plus. If it is descending, we want to increment current run length by 1. So just copy that over. Then if it's in neither of those situations, then we want to, first of all, like, I guess just check if to see if current run length is greater than the longest run. So that's just be something like if current run length is greater than longest run, then we want to reassign longest run to current run length and then zero out current run length. Be 1. Okay. So if we have that, what is this? Oh yeah, that should be over there. Okay, so this is neither. This is ascending. And so if it's ascending, we want to check to see. Wait, where are we? It's here. So we're incrementing that value. So, and then just continue. Actually, we don't even need the continue because of how this is working. Else if, else. Okay. I don't want to run it right away. I feel like there's something wrong with it. Or to think about this, I have like 12 seconds. I guess I have to run.
Usually you get like 40 minutes on this, so, or an hour, but.
That's true, but I don't know. I feel like this was, I don't know. We'll see. We'll see. We'll see. So longest run, let's just return that value. 3. Okay. So that's just wrong. And so it's seeing, okay, so that's just very wrong. So let's think about what's actually happening here. So we're checking these two and we're checking, so it's ascending. So then we're incrementing something. And I feel like we need a switch, right? Because this is like literally, I think just there's no like through line for the, like, if it's consistently ascending. So how do I do that? I guess here, okay, so I think we do need like some sort of initial something. So I think I'm going to declare, so let is ascending, and we'll just initialize that to some like ascending function where we're passing in input at 0 and input at 1, just to get like an initial value. And I'll just write that up here, const ascending. Okay, and then just a arrow function. So basically we just want go left, right. So left. So this is ascending. So left is equal to right minus 1. So this is a predicate. It should return Boolean. And let's just, I'm just going to test this in isolation. Actually, we'll just do return ascending. And then it could be like 1 and 2. And we should just see what that returns. Okay, so it is ascending. Just verify 2 and 1. False. Okay. That looks good. So it's working. So we've got that. Okay, and then we need, so now that we have our is ascending, like sort of like toggle, if we're looking at this, it's like, is it, first of all, is it ascending, right? So we need to check here. So is it ascending and was it ascending? So maybe I should rename that was ascending. So then if was ascending is true and that expression is true. So this is essentially previously ascending and ascending by 1. Okay, and then we have to do the opposite for that. So if was ascending, previously ascending, and there, okay, and then this one would be if was not ascending, and that expression. So previously descending, and descending. I don't think that's how you spell ascend. I feel like that looks wrong.
No, that's right. That's right.
I don't know.
Yeah, that's right.
For some reason it looks wrong. Okay, so if it was ascending and this, then we would here we would just have the last value. So was ascending is still equal to true. And then here was ascending be false. Okay. Wonder, still 3. Damn. So there's something wrong. So if current length is greater than longest length, well, I mean, I guess I could just like see it, what things like what's actually happening here. Or I guess maybe you want to log current run length. So wait, is there another log or something? I'm not seeing that. So 2, 3, 1. That's just wait. Current run length. Maybe I want to have a statement here. Break chain. So like breaking the chain of ascending or descending. And we'll just see where that is occurring. So we're just breaking the chain once. And that seems right, because it's like ascending, break the chain here. Maybe we want to print the index too. So we're breaking the chain at index 3, which is correct. Okay. And then maybe if
I have a quick question. So how are you checking if it's ascending or descending after a break? Like after a chain break?
yeah, that's a good question. Because the was ascending. Yeah, oh shoot, okay. Do I need like another pair of pointers to check like, no, I don't. Yeah, that's a good question. I'm not sure.
I mean, you could just put was ascending, keep feeding them different inputs in the else statement once it breaks, because then you need to update the was ascending or was descending.
Yeah. Because like there isn't like there like when we reach this else clause, we're like it is no longer relevant if it was ascending or descending because we're starting over.
Right.
Right. So how would we handle that? Shoot.
You could do it at the very top, starting at the for loop, and just check for every single left and right if it was ascending or descending. But
Yeah.
it's a little bit complicated keeping track of all the indices, though.
Yeah. That, yeah, I mean that's I think that probably would work. I'm sure there's a more elegant way to do it. Just like missing longest run, right? Run. Okay. Maybe just return to this. So we declared that starting here, declaring left and right. So we're hitting the else condition, and that logged out the string and the index of 3, which is where we are breaking the chain. So when we break the chain, if the current run length was greater than the longest run, we want to push that in to, or I guess we want to reassign longest run to that value. And then we would reassign current run length to 1. So maybe I was wondering if we could do something with this, where like we could check like if the current run length is 1, then I don't know.
Then check if it's ascending or not at that point.
Yeah, so if it's 1, then I guess that would mean that we wouldn't need to do this before the loop. It would just be like here. Oh, wait, is that it? Is if so, I guess I'm gonna try to express it in English. So like if the current run length is 1. So this is either like at the very beginning of the loop or when we've hit this condition and we've zeroed or 1 the current run length. We would want to see, okay, is it ascending or descending at this point? Yeah, maybe that's so if current run length is equal to 0 or is equal to 1, then we would want to perform this operation. Right, we want to perform was ascending, maybe assign was ascending to left right, maybe. So like if I were to do that, it'd be like if current run length is equal to 1, then we want to invoke, we can maybe do was ascending equal to ascending left right. So then we would get that for the current window. And then from there, maybe, does that seem like the right place for it to happen?
Yes, because I think you have to constantly update that.
Okay,
Yeah.
so if I were to just do like, could just set this, we can just leave it uninitialized, or actually we should probably leave it to 1. Wait, no, that's was ascending can just be whatever at this point. Yeah.
And then
Okay.
quick question. So you're checking was ascending, but then your new left and right indices, it's gonna be the same because you need to increment the left and the right, right?
Are you talking about for this portion?
No, for the next if statement, because you're kind of checking the same indices if they're ascending, but you have to check the previous one and then the current one. So I'm just wondering how you're going to update the current one.
That's a good question. Yeah.
I mean, you can just, after checking left and right, you could just increment it by 1 and see what happens.
Increment the index.
Like, yeah. It might miss something though. So
Yeah. Okay. So,
I mean, you could try it. I don't know.
Yeah. I mean, I feel like we're still broken. So what is that logging out? That's logging out current run length. So why would it be? It should always be like once it reaches 5, it should never be reassigned. Like we're like seeing that, right? We're seeing 5.
Yeah, that's very strange.
So why would it be being reassigned?
Let's see what happens. So it keeps looping through to check, and then else it goes into the else loop. If current length is greater than longest run. I mean, I don't even know if you need that. Oh, you do need that else check. Okay. I did it somewhat differently. Okay. Why is it going back to 3? That is really weird. Could you print out before going into this else loop current run length and then longest run?
Yeah, you mean just like up here?
Yeah.
Okay, so current run length and longest run. Okay.
Yeah, I'm curious what that's gonna show.
Comment that out. So wait, that's confusing, right?
Yeah.
Because it should, okay, so we're just thinking about this like on like a line by line basis. And we're looking at the first test case, right? So it's 1, 2, 3. It should immediately be assigned to 1 because oh wait, we're not even,
Because you're still in that loop was ascending, or yeah, you're still in the was ascending if statement.
yeah. I think this might be a situation where like I don't actually want this else and
I
I
don't think
actually
we
want to
do
use,
either.
I think it might be like we should just continue and then continue. Oops. Continue and then just not have this.
Yes.
So we get rid of that. Then we can just bring this back. Oh god. So then that's going to be checked.
There you go. Every time.
Well,
Yeah.
maybe this is right. I it still looks like it's wrong. Uh,
I don't understand it.
so I mean, I guess this was just bad code. Like I think something wrong here.
I don't think it was bad. I think that the way you walked through it was really good.
I mean, yeah, it's, I don't know. Like I appreciate that. I just like it would be nice to get it, like in the like have it actually translate effectively.
Well, maybe you just need a little break. Think about it. Come back to
mm,
it.
Sure, yeah, for sure.
I'm also happy to keep working on it. I'm also happy to show you what I did.
Yeah. I'll stop sharing my screen.
Okay.
Look at that.
How do I transfer this? Oh, I have to exit this. I'm gonna move it onto my laptop so you can actually read the code.
Okay.
Because on that big screen, you probably can't see anything. Okay. Let's see. Share screen. Oh, I can't share my screen.
Oh, sorry. I can make it that you can. Okay, you should be able to now.
Okay, awesome. Okay, sorry, you're gonna see yourself for a second. I hate when that happens to me. Okay.
Hide self view.
Yeah. Okay, sweet. So I'll talk through what I did. Basically, I had taken a vector int. I set the max run to 1 because it's always going to be 1, basically. And if there's anything bigger, then update it, So I basically loop through the array. I set the current length within this loop. Also, I got the increasing and decreasing wrong. This is actually decreasing. It's so easy to do. Anyways, so I check if it's decreasing. And then if it's decreasing, I increment the current length. Then I set the current index to I within this for loop. And then
Okay.
while current index is less than array dot, so I basically go into another while loop and I check if that next index, like we incremented it, if it's still on the same trajectory of I say decreasing, descending. Then I increment, or else I set I to the current index because I don't want to have to loop through that for loop again. Because I just did it within this while loop, if that makes sense. And then I update the max run length, basically, if the current length is greater than max run. I do the same thing for if it's ascending. Enter into this while loop, and this just like I hope you see what I'm seeing here, like updating I, because I don't want to repeat myself. Because here is I in this for loop, so I make sure I only hit every element once. And then I do the same check right here, and then once it's looped through every single index, yeah, I return max run. And then here I can run it if you want to see what happens. So I get 4 and it should be 4 here. And then let's just make sure it works for ascending. I didn't do all the checks you did though for empty arrays or anything. Okay, 4 is correct too. And then let's say we do like, we can set this to 100. Curious. I haven't tested it.
That should be 3 then, right? Okay, yeah.
Yeah.
Nice.
So that's kind of what I did. I'll stop sharing. But that's kind of where I was going, where like you can check first and then you can go within that while it continues to do this pattern, you know. Because I
Yeah.
originally thought the way you thought, I was like, I could just have a bool of like, and then once I got to that thought of having a bool, I'm like, I don't get it. Like, I guess there could have been a check for a bool like changed direction or something, or
Yeah, I mean that's that it
like
I feel like it gets weird when you start creating like, would that be like a verb sort of like action terms, you know? Like I feel like that's like, I mean, I was doing like, have you done the one matrix problem that's like spiral matrix?
Oh yeah.
Okay, like I was trying that one the other day and like I was totally lost. Just after we had done the other spiral one, and like the whole like directional sort of like behavioral stuff where you're like simulating something is hard for at least for me to like express sometimes with code. Like how do I do that?
And it's so picky in terms of keeping track of the indices or the index that you're at, like, and like incrementing and like not like it's such a visual thing for sure.
Yeah, I mean it's weird. I actually so I just like changed the code that I was looking at, and now I'm getting 4 being logged to the console, which is like, so like I guess the problem was that I had those those continues for there and actually it was here and here. I had those continues, which
Oh, so
essentially just like,
skip the if statement. Ah,
yeah,
okay.
it was missing that, but it's still hitting 4. So I'm like a little confused. I wanted to maybe console log do the same thing. So current run length and longest run. And then maybe we'll just return undefined for now. So it's immediately being reset, and then 2. So it's like missing 1 count. Which I think, I'm wondering.
Oh, and not, oh no. Yeah, interesting because you increment each time. I think it's because you're double checking the same index on line 85 and 89. I think because you're checking the was ascending and you're passing in the left and the right twice. Do you see what I'm saying in the and part? So you check was ascending for the left and the right index, and then you check it again to see
For the same pair, right?
Yeah.
Okay.
So I'm curious if you were to do left +1 and right +1, but you would have to increment the index. So maybe update it again after that, check the was ascending thing.
So wait, so you mean like, what do you mean?
So if you go to like, let's say, just type in code at line 85, and if you do left ++, does that increment the index or does it?
That'll increment the value of left.
Oh, how do you increment the index? Because I'm curious if
just do like maybe just like create another variable like previous left or something.
Yeah, this would be next left though, because you checked the previous. Oh, I guess next left.
And then just be like input minus or I minus 2 or
No, I would do I plus. I would do I and then I +1 for right.
yeah. Oh yeah. Okay. So then let next right equal input I plus 1.
Yeah, I'm curious what happens then. I have a intuition it's still gonna be wrong, but like, and then you're
Yeah.
checking previous if it was ascending and the current one.
Yeah, so this is checking current. Or no, so I guess this should be next left and next right.
Wait, previous though, because it's before, right? Because your was ascend like were the previous indices ascending?
Yeah.
Yeah.
Yeah,
So
no, that's
down here in the left equals right -1. Try next left, next right.
yeah. Next left, next right. Okay.
I'm so curious what's gonna happen.
And then the same.
Same for the lower one too, yeah.
Okay. Next left, next right, and then no other occurrences of those variables. Wait, what isn't it like this? Next. Oh, it's right. Okay.
Interesting. Okay.
So
Yeah,
yeah.
I knew it was gonna be bad because it accesses elements that are out of it. But if you tweak around with that, like check the
Yeah.
previous and then the next, I'm sure you could get something.
Yeah,
And
I feel like this was one where like it was sort of close. Like maybe I could have gotten it, but it was like just yeah, it didn't happen this time. But yeah, this is very
well,
fun.
if it's helpful to know, like I know a lot of people. Yeah, I was just gonna say like a lot of people like go through coding interviews and they don't solve it, but they walk through everything, they show what they are thinking, and you talked really well through it too. So like I'm sure they wouldn't totally pass on you or anything.
I mean, it always, I mean, thank you. And I have been working on trying to be expressive and like express what I am thinking as I am thinking it. But sometimes I feel like I just do better if I'm just like quiet, like to actually solve the problem. But that's not all they're looking for, right? Like they want you to be able to communicate, which is tough. But yeah, do you want to set up another mock for you like this coming like weekend or something?
Yeah, that sounds perfect.
Cool.
Yeah.
Do you want to send? I'll like send you a problem. You can send me a problem.
Yeah, we can do that same thing again. Yeah.
Perfect.
Yeah.
Cool.
I might have some plans. I'm not sure yet. But if I can't do this weekend, would you want to do like Monday?
Yeah. I mean, I'm again,
Would
we're
Monday
on
work,
like a
or
similar.
Tuesday?
We're on a similar schedule, I think, as far as
Which is great. Yeah.
Yeah. Cool. All right. Yeah. Let's plan for maybe like if not this weekend or early next week. Yeah.
Okay, that sounds good. I was gonna say what else. I had a little bit of feedback. I was just saying
Oh
I
yeah.
really liked how you did the requirements and like you defined what certain terms meant. Also how you talked about what variables you wanted to store before even doing the problem. That was good. And then the test cases were awesome because sometimes I'll just do one input and output and it's a really simple one. But if you get test cases with like edge cases, that's awesome. So that was really cool and it definitely helped me. One more question. What do you think the time complexity of your solution would be?
Yeah. As it stands now is not a good solution. It's O of n. Because
Hey,
we're
that's
just
not, you have to do that
what?
for that problem. I'm pretty sure you have to, that's like the best you can do with that, no?
Yeah, I think so. There's probably something really like clever you can do. Maybe like with I'm thinking maybe some sort of like maybe like a regex or something where like you would convert them all to like string characters and then but I'm not and then like I don't know, maybe that's probably still touching on every single element.
I think you kind of
yeah.
have to, I'm pretty sure. I'm gonna research online and see what the best solutions are now.
Great. Yeah. No, that's cool. And let me, I'm thinking if, do you want a problem that's kind of more like this style to like for you to do?
Sure, I'm super easy. Whatever you think is good. I'm really flexible and just doing a bunch of different stuff I think is helpful. But they do test arrays a shit ton. Like that is probably the number one tested thing I've seen in interviews so far. But
Yeah.
so whatever you want, whatever excites you, just send it over.
Do what excites.
Yeah, yeah.
Perfect. Well, yeah, have a good rest of your day. And
Oh, you
I'll
too.
talk to you probably this weekend or early next week.
Okay, that sounds good. Okay, bye.
Peace.